Cloud Computing by Michael Casella, Vivian Dinh, Christopher Kellum, Tarik Marik, and Geoff Waterer. Brief history and timeline of cloud computing development. Cloud computing history. The term cloud is used as a representation of the internet and other communication systems, as well as an idea of the underlying infrastructures involved. What we now refer to as cloud computing is a result of an evolution of the widespread adoption of virtualization, service-oriented architecture, autonomic and utility computing. Details such as a location of infrastructure or component devices are unknowns to most end users, who no longer need to thoroughly understand or control the technology infrastructure that supports their computing activities. Following is a brief history of this evolution. Early 1990s. Beginning in the 1990s, however, the Internet began expanding their offerings to include virtual private network services. This allowed the telecom companies to provide the same quality of service at a fraction of the cost, as they were able to optimize resource utilization in order to improve the efficiency of their overall bandwidth. The late 1990s. In these earliest stages, the term cloud was used to represent the computing space between the provider and the end user. In 1997, professor of Emory University and the University of South Carolina defined cloud computing as a new computing paradigm where the boundaries of computing will be determined by economic rationale rather than technical limits alone. This has become the basis of what we refer to today when we discuss the concept of cloud computing. During the second half of the 1990s, companies began to gain a better understanding of cloud computing and its usefulness in providing superior solutions and services to customers while drastically improving internal efficiencies. In 1999, Salesforce.com became one of the first major movers in the cloud arena, pioneering the concept of delivering enterprise-level applications to end users via the Internet. The application could be accessed by any customer with Internet access, and companies were able to purchase the service on a cost-effective, on-demand basis. The early 2000s. Shortly after Salesforce.com brought this new concept to the world's attention, Amazon.com proved it could outlast the dot-com bubble burst with the introduction of its web-based retail services in 2002. Amazon was the first major organization to modernize its data centers, which were utilizing only about 10% of their capacity at any given time, which was very commonplace at the time because companies were worried about sudden spikes in capacity needs. Amazon realized that the new cloud computing infrastructure model could allow them to use their existing capacity with much greater efficiency. With Amazon's web services, they provided a suite of cloud-based services including storage, computation, and even human intelligence through the Amazon Mechanical Turk. Then, in 2006, Amazon launched its Elastic Compute Cloud as a commercial web service that allows small companies and individuals to rent computers on which to run their own computer applications. The late 2000s. Meanwhile, Google had become a key player in the Internet commerce marketplace. In 2006, the company launched its Google Docs services, which brought the power of cloud computing and document sharing directly to end users. Another big milestone came in 2009 as Web 2.0 hit its stride, and Google and others started to offer browser-based enterprise applications through services such as Google Apps.
An overview of information systems. What is an information system? Basically, is a set of interrelated components that collect, manipulate, store, and disseminate data and information and provide feedback to meet an objective. The components of an information system. The first is input, which basically all it does is it gathers and captures raw data. The second is processing. With processing, you're taking the input and you're converting it and transforming it into information that you can use for special purposes. Then you have the output, which is where you're taking the information that you've already processed and you're using it and transcribing it into documents and reports. And with those reports, you're getting feedback, which with the feedback, you're using it to forecast future events and planning for those future events. Components of a computer-based information system. First is hardware. Hardware basically includes storage, processing, the input and output. Then you have your software, which is Windows or Microsoft Office. Then you have databases. Databases which are used to store like online purchases or sales information, customer information. You have telecommunications networks and internet. An example would be the Boeing Scan Eagle, which was a telecommunication. Then you have the number one element for a computer-based information system, which was people, who basically are used to manage, run, and maintain the system. Lastly, we have procedures, which include a number of things, such as like policies, rules for using strategies, and some of which include like operation, maintenance, and security. The types of information systems, they include the electronic and mobile commerce, such as business to consumer and consumer to consumer, which use wireless devices and wireless communication. Enterprise systems, such as the enterprise resource planning and a transaction processing system, which is used for employee payroll processing. Then you have your information decision support system, an example of which is Management Information System, or MIS. Then you have specialized business information systems. Some of the most popular ones are artificial intelligence, virtual reality systems, expert systems. An example of an expert system would be someone who actually specializes in a specific field, who knows the field really well. Say, for instance, a robotics engineer. Strategic planning for a competitive advantage would with information systems. First, they help maintain, lower prices, increase productivity and efficiency. Then they can help produce a wider variety of services. Then it can help deliver products to smaller demographics. They can help improve the product lines or product families. And then they can also introduce innovation or concept to the industry. What? I don't know. No, where I saw that. I don't think that. So. The responsibilities in information system. First, there's operations, which in operations, the system operators basically help deal with the everyday issues of the system, such as starting and stopping, scheduling, then there's the system development, which is basically the ongoing maintenance, and the system analysts handle all that, and they handle any related problems, such as when the system goes down. Then you have the support, which they just provide assistance to those who would actually like to learn things like about the hardware or software that they purchased. The global challenges in information systems, well, they're demographic segmentations, and those are basically the cultural or geographic. Then you have diversity, which diversity information systems deal with a lot of language, there's behavior and personality differences. You have regiocentric, which deal in time zones, language barriers, government policies. An overview of information technology. So what is information technology? It's the use of systems and the storing and retrieving and sending information. The types of information technology. The most common use is mobile phones, such as the Apple iPhone or the Samsung Galaxy. Then you have computers, such as desktops, laptops, and netbooks. Some of the most popular ones or the MacBook Pro, or the MacBook Air, or Microsoft Surface. Then you have computer accessories, such as flash drives, external CD Blu-ray drives, or now you have cloud drives. Then you have software, such as internet security, utility software. You have Microsoft Office, or even you have tax software. The relevant components of information technology. The main five are hardware, software, data, people, and procedures. But another component is telecommunications, which adds internet and networks. The types of different software. Basically, we have the three main types of software are operating systems, utility software, and application software. Operating system software are basically like your PC softwares, such as Windows-based software, such as Windows 10, Apple's OS X, Mountain Lion, Linux. Your utility software is basically things like Norton Utilities, your Adobe Acrobat Reader Pro, your Drive Scrubber. Your application softwares are things like Microsoft Office, Microsoft Project or Publisher.
Platform as a service deploy. Cloud service model organizations create their own applications on rented platform. User has control over application but has limited or no control over the underlying infrastructure. Some examples are the Google App Engine, Salesforce, and Microsoft Azure. Cloud computing. This allows people to get information they need from the internet, which is the cloud, versus from desktop or corporate computers. Infrastructure as a service. Cloud service model. Customer use only the apps provided via a cloud infrastructure, Gmail, Google Docs, or the CRM system. Likewise, Amazon, Rackspace, FlexiScale, and Compute Next.
Relevant costs. The goal of a business is to minimize costs and maximize profits. Therefore, an understanding of cloud computing's relevant costs is crucial to understanding why so many companies are switching to this newer technology. Opportunity costs are at the top of the list. By looking at opportunity costs, a company gains an accurate measurement of the benefits cloud computing and alternatives offer. This allows for a company to make the best decision. Knowing your opportunity costs also helps a company compute their total cost of ownership. TCO, or total cost of ownership, is an equation that accounts for all forms of costs and gives a company a true metric of costs incurred over a period of business operations. Capital expenses are a very relative cost because switching to the cloud requires no capital investment. By moving data to a centralized, privately operated storage system, the need for hardware software licenses to store data and share information essentially evaporates. This can save company large amounts of money. Operating costs transition from a complex cost model to a pay per unit cost system. The price to use cloud service providers is transparent and is recorded based on how much RAM storage and bandwidth is provided. The use of a cloud computing also eliminates a large portion of IT needed. This causes labor costs to be reduced significantly, allowing a large cost savings. Here on this graph is an estimated cost of infrastructure for 2 application servers, 2 database servers, and a local balancer across internal managed and cloud deployment models. As you can see, consistently over many of the relevant costs, the cloud offers a cheaper or equally priced solution. Overall, this solution results in a 29% cost savings. As stated within the relevant costs, cost savings proves to be one of the largest benefits of switching to the cloud. One of the most significant benefits of switching to cloud computing is the considerable savings in IT costs. Also, by moving to the cloud, companies of all shapes and sizes save substantial capital because they no longer have to spend money on equipment, infrastructure, and software. Another major benefit of switching to the cloud is scalability. One of the most intriguing benefits of moving to the cloud is the fact that it can be adjusted to fit business needs quickly. This keeps companies from having to spend money before it is actually needed. What goes right in hand with scalability is efficiency. Cloud computing gives businesses the ability to communicate and share more easily outside of traditional methods. The cloud system allows for employees to collaborate through the ability of multiple users and share and work with the same data at the same time. Also, flexibility within cloud computing allows employees to be more flexible when it comes to completing work. For example, they have the ability to access data from home, on holiday, or even by their mobile device. Something that also proves very important for companies is the improving forces to become more environmental. By using cloud computing, central databases, less equipment is used and a substantial amount of carbon footprint is reduced. Although there are many benefits within cloud computing, some risks occur. Unauthorized access to customer data proves to be one of them. Cloud services collect data from thousands of small businesses. This makes cloud service providers a popular target for hackers. In addition to the threat of hackers, cloud service also face threat from ill-intentioned inside users. Another risk is security risks at the vendor level. When a cloud service vendor supplies a critical service for your business and stores critical data such as customer payment data and mailing lists, you place the life of your business in their hands. Ownership also is a big risk. Often the customer is not the only owner of the data. Many public cloud providers, including some of the largest, have clauses in their contract that states that the data stored is the provider's, not the customer's. Availability also is one of the benefits but proves to be one of the risks. Almost everything today is synonymous with the internet. The cloud is no different. This, however, has a drawback. When internet service providers lose connection, cloud users can be left with their hands tied behind their back.
Business uses and implications of cloud computing. Businesses, large and small, should use cloud computing for many reasons. Reduction of costs. The use of applications in the cloud can be less due to lower hardware costs for more effective use of physical resources. Universal access. Employees can access the application and work from the internet. Up-to-date software. A cloud provider will be able to upgrade software. Choice of applications. Cloud computing allows a business to use, access, and pay for only what they use, with a fast implementation time. Cloud computing can change the way you do business. Plug-in players are businesses that plug into cloud-based service providers. Zen Payroll is an example. The company automates and handles all payroll taxes, filings, and forms so that small businesses never have to fill out government documents. 40% of businesses today that require payroll process it by hand, and 1/3 of those get fined every year for incorrectly paying their payroll taxes. By plugging into the cloud-based providers such as Zen Payroll, small businesses will be able to focus on mission-critical areas of business. Advantages of using cloud. Head-to-headers. are small businesses that are able to compete with major firms for businesses, all because of cloud. An example would be Airnet. Investment banks that have between 3 to 5 employees are able to compete with large businesses because they are taking advantage of the capabilities that cloud provides. Hives are businesses that operate with employees working in different locations and companies that have increasingly flexible staff levels. Cloud is enabling all this to happen. Cloud services business owners use. Public cloud. Service is built on an external platform run by a cloud service provider. A public cloud system is great for organizations that want more elasticity, cost effectiveness, and the latest technology. Private cloud is a cloud platform built on your own hardware and software. It is ideal for businesses that want exclusive access, more flexibility, and greater control of their cloud. Hybrid cloud uses both private and public clouds. Hybrid cloud has its own IT team manage part of the cloud in-house and the rest off-site. It is perfect for an organization that wants to manage business-related data in-house, but wants to store less sensitive information with a third party.
The future of cloud computing. Since 2013, the SaaS market has grown yearly at a rate of 20.2%. By 2017, it is estimated the cloud computing market will be worth over 168 billion euros. 65% of businesses using the cloud will adopt a hybrid environment by the end of this year. Only 1/4 of the 18 million software developers worldwide were working on a cloud computing in 2014. Future trends. Market will accelerate faster in 2017 as enterprises seek to gain efficiencies as they scale their compute resources to better serve customers. Enterprises with big budgets, data centers, and complex applications are now looking at cloud computing as a viable place to run core business applications. While already relatively flexible, cloud computing will become more flexible in the future. This will mean that the uses and needs it can serve will increase, as well as the number of businesses that will be able to take advantage of it. CIOs who initially elected to build private clouds may find themselves switching to public clouds as they realize just how time-consuming and costly the work will prove. Capital One shuttered private cloud efforts in favor of Amazon Web Services a few years ago. We recognized that we were spending a lot of time, energy, effort, and management bandwidth to create infrastructure that already exists out there in a much better state and is evolving at a furious pace, says CIO Rob Alexander. Software will almost fully break away from hardware, as companies are beginning to find applications online more valuable, which eliminates the need to keep purchasing new servers. As developers realize the benefits to moving the heavy lifting required by their applications to the cloud, they will move them over to reduce demand placed on users' machines. This will increase the number of systems that are capable of running their applications and can also lead to increased performance of the application. Top reasons for cloud computing. Large companies will create private cloud networks. Large companies such as IBM are increasingly seeing the advantages to owning their own cloud networks. The networks are flexible, scalable, and cost-effective, and because they can be secured in the way the company chooses, they are safer. Cloud adoption will continue to trend upward. As more and more companies at all levels of the market begin to see the benefit of the cloud's flexibility, cost savings, and scalability, the growing trend of cloud adoption will continue to rise. Some of this demand would be driven by customers who increasingly expect services that can only be offered effectively through cloud computing. Compression techniques will be important in lowering storage cost. As more and more storage moves to the cloud, keeping an eye on price per gigabyte will be important for companies who wish to keep costs down. By implementing new compression techniques, companies will be able to store more data and reduce the storage cost. Analytics will become a big cloud future. Analytics are a perfect fit for cloud computing. They require large amounts of processing power, but are only used a few times a year. Having expensive hardware that is idle most of the time is expensive and wasteful. Outsourcing analytics as a cloud service will be a more cost-effective way for businesses to get the analysis they need when they need it. Large cloud databases will centralize huge amounts of information. While this may seem obvious, it is going to be huge. Think of it as the way that Wikipedia centralized knowledge on the internet. This will be the way that cloud computing will centralize information in the cloud. Large databases of information regarding things like stock market analysis or patient medical information will all be accessible in a single place, creating powerful resources that will vastly improve many industries and markets.